Hi everyone, in this video we're going to be going through this document, Thunder and Lightning. Right at the beginning, disclaimer, I'm not going to make you do anything with this in the course. This won't be something I would ask you to do on your own, but I think it's a pretty neat thing that we can apply some of what we learned to so far to the situation and make some use out of it. Just kind of a neat thing to do. And so the whole plan of this is to give us a way to fairly accurately, it's not perfect, but we're going to do a pretty good job, predict how far away a lightning strike was from us. As long as we can see the lightning strike and hear the thunder, we'll be able to do this. So just being able to see the strike and then listen for the crack of the thunder, we'll be able to calculate about how far away that actual lightning strike was. All right, so getting to the start of this, there's two things you might think you need, and I have a little picture for us in just a second. So the first two things I think that might come to mind are how fast the light and the sound are moving from the lightning strike to you. Now we're going to make a simplification here that's really important for us to be able to do this little trick. So right here you see it says the speed of light is 299 million meters per second. So that's so incredibly fast that if you are looking out on Earth and you see a lightning strike, the time it takes for that light to actually travel from the strike to your eyes is so tiny. It is basically instantaneous. So we're not going to actually think about that aspect of things. We are just going to make the assumption that as soon as the lightning strike happens, that light is already at your eye. We're going to pretend there's no time between. So why is that important? As soon as you see it, you're going to start the clock in your head. And so we'll get to what you're starting the clock for in just a second. The other piece of information is the speed of sound. So the speed of sound is much slower. And this is not always true. You can look it up. The Wikipedia link is here, and you can check out the formula for this and what's important. We're going to simplify and say that we are in the right conditions for the speed of sound to be 343 meters per second. Still pretty fast, but compare these two numbers. Much slower than light. Okay? So sound is much slower than light is. All right, and so that actually is just the key to this. When we want to figure out the distance from you to the lightning strike, right, we are basically just focusing on how long does it take for the sound to get to us. And we're going to use this idea of speed to figure it out. So here's the setup. So here you are. This is you right here. And then a lightning strike happens. And again, the light, it does technically have to travel this whole distance to you. Okay, that we want to find out, but it goes so fast that it's not something we can really even distinguish. So we're going to pretend the light just basically instantaneous. It happens, you see it. So that's in your head. Lightning strike happens, and no matter, if you can see it, if you're in a radius big enough to see it, we're just going to pretend that it's instantaneous. You just see it as soon as it happens. But if you've ever, seen one of these storms, you've looked out the window, been outside, you'll notice that you can see lightning happen, and then you have to wait a little bit to actually hear the sound, the thunder. So the lightning and the thunder are happening at the same time, but the sound takes a while to actually travel to your ears. That's why it's delayed, and that's what we need. We're going to use the delay of the sound wave to figure out how far it had to travel. Okay, and the way that we're going to do that is we're going to say, okay, well, we've got down here, we have a formula. Distance equals rate times time. We've used this formula already. We used this in the last unit, right? So we're going to keep playing around with this, and we're going to use it again in this unit. And so here, when I'm saying distance, I specifically am talking about the distance from you to the lightning bolt. This is the distance. This is what we want to know. And so our question is, okay, the sound wave starts here at this blue start point right here. The sound wave starts there, and then it takes some time for it to travel along all of the all of the molecules it's bumping into, all that crazy stuff. So it takes a little while for this to travel to your ear. And so the length of time it takes, that's our time. The distance that it actually moves, that's what we want, that's the distance. And then the only other piece of the puzzle we need, go back down, is the rate, the speed. How fast does it go? Okay? So, how do we use that? Well, first things first, I already gave you this. We know how fast speed goes. Again, this is, the rate is how fast sound travels. So how fast sound travels, we know that, okay? And so, all right, what do I want? Remember, I want to know the distance. So I want to know the distance. So just like every other problem here, in order to solve and find the answer to a question like this, I need two things, and I can then find the other one. So that means I need time, t, right here. I need this information to find the distance, right? So here's what we do. Let me go back up to the picture. So we're sitting here. We see the lightning. Again, the light has to travel to us, but it's so fast, we're going to pretend it instantly travels to us. So as soon as we see this lightning bolt hit down, or, you just see the sky light up. Same thing. So you see that light. You say, okay, the lightning bolt has just happened. Let me start counting. 1 second, 2 seconds, 3 seconds, 4 seconds, crack, and then you hear the thunder. And so if you do this process, you have found the time it took for the sound to travel through the air into your ears. So we plug that in to our equation, and we'll have rate times time. We'll have two numbers there. We multiply them. We get our distance. Okay? So here's an example. Daisy sees a lightning strike, or just sees the sky light up, and hears the thunder 2 seconds later. So she sees the sky light up. She goes, oh, it's happening. 1 Mississippi, 2 Mississippi, and then boom, crack. She hears the crack. So she puts 2 seconds in here. All right. So just because I can't not do this, right? Let's check our units. Our units here, let me write them out. Just units are meters per second times seconds. So we got to think, okay, does this work? What's going on here? Well, seconds on bottom and on top, that's going to cancel out, right? So that's really good. What happens? That leaves me with just meters. And then I go over here, say, okay, well, I should just be left with meters. Does that make sense for distance? It does. Awesome. So I know that I have that set up right. I do my calculation. I end up getting 686 meters, which, if you prefer miles, feet, whatever, you can convert to that. I just did that for you. That converts to about 0.42 miles. So in 2 seconds, the sound wave, so what are we saying here? We're saying, right here, it took 2 seconds for this sound wave to travel from lightning bolt to you. Using the fact that we know the speed here, we can determine with that equation that this distance had to have been 0.4 miles. There you go. That's it. We count how long it takes the sound to get to us. We multiply by the speed it's going. That'll give us our distance. Rate, speed, times time equals distance. We're just using that formula. Just being creative with it. So you might think, okay, well, that's well and good, but I don't really want to have to remember multiply by some number. So how do we make this into like some kind of actual thing that we can use? So if you want to do this as something that you can tell a person or you can just use, so you don't have to actually multiply things like this. Here's what you do. You say, okay, you know what, let me just focus on what happens in 1 second. You'll see this a lot. It's almost like we're kind of doing like almost like a unit price of this. It's, what's kind of happening at the base level, 1 second. Well, using the equation, we plug in 1 second into here, and we end up getting that the sound wave, so what does this mean? The sound wave will travel, and you can round this to make it easier on yourself, right? The sound wave will travel 0.20 miles in 1 second. So if you can just remember that 1 second is 0.2 miles, then all you have to do is just keep adding that up. And so just as a couple examples, right? So, just as an example, you do this again. Here's another example. Okay, you count 5 seconds. See the flash. 1 Mississippi, 2 Mississippi, all the way to 5 seconds. Well, then how do you know how far it is? Just take your 2.2 miles, and then you can either multiply by 5, or, don't forget, you can just add it 5 times. These are the same thing. Whatever's easier for you to remember. Either way, 0.2, you're going to get 1 mile. So that's another rule of thumb. If you prefer that, you can remember 5 seconds is 1 mile away. Okay? That's it. So your rule of thumb, if you want to, can be for every second that passes when you're counting, add 0.2 miles. Okay? All right, so that's it. Now you can go use that. You could go tell your friends you're in, there's a thunderstorm. You're like, whoa, watch this. And then you figure it out, and most likely they have no way to check it. So you'll sound awesome, but it's working, and you're not perfect, but it's true because we did the math to show it. All right. So I'm just going to assume I have to do something like this. Don't go outside and try to do this. Do it out the window. Okay. If you're going to do this, you're going to test it. You're going to say, Mr. B told me about this thing, and he told me to go outside and do it. I did not do that. Stay inside, please, during thunderstorms. Don't go outside with metal things. Very dangerous. And now you can know if you're outside and you see the flash and you go, I wonder how far away that is. Well, start counting. 1 Mississippi, 2 Mississippi, crash. Well, that means it was only 0.4 miles away. That's not very far. You better get inside. If you only hear 1 second, you better run inside. So use this as you will, but please don't try to go outside to test this. From the safety of your own home, the next time there's a thunderstorm, you can try this out.